morning, boys and girls. Welcome back. We're going to start disassembly of this bad boy. Don't know how far along we'll get this morning, but I've pulled all the tubes, put those in a safe place, and I have got my small schematic that I have laid out. The other thing that I've got to do is I've already printed all my material, but this particular layout and wiring diagram has the color of the wires where the schematic does not. So in the future I will enlarge this and maybe get me some colored pencils. But as you can see, I've got my 1-inch binder with protected, and I've got some documentation that I'll go through. I've started my drawings or my documentation on my papers. Not only do you want to take pictures, if you can, videotape your stuff, and do a lot of hand drawing and note taking, because there's notes that I take that's not on schematics or may not show up in my videos. So the first order of business is when we slide this out, the speaker connection is on a terminal strip in the back, and there's 4 wires going to 3 connections in there. So what I'll do is I will come in and we'll mark these wires. Now these wires, as you can very well tell, are going to have, they're cracked. We're going to have to replace those anyway. I could just cut those, and but first thing I need to put labels on them until I get them replaced, and then when I replace them, the replacements will have the same labels on them. So that's very important, and you do this stuff one at a time. I expect when we get in here we're going to have to do quite a bit of rewiring, which is just time consuming, point to point, and routing the wires. Make sure you get them to length and everything, and good solder joints, and get everything cleaned up. So it's just time consuming. It's not rocket surgery or brain science or anything like that, but it's going to have to be done. The transformer, the AF transformers, I don't think, since we're not going to have to do anything with those, I think I'll probably leave them in place and just clean this can up and maybe shoot it with some paint. We'll see. But the capacitors, we're definitely going to have to do something with this can. Now, when we get under the bottom, we may want to, not pull this and restuff it, but we'll see. But we're definitely going to replace the caps in this box, so in one form or fashion. So that's pretty much it for right now. We'll let me go ahead and mark this, and we'll pull this chassis out, and we'll get a look under the bottom. I pulled the chassis out, and while we're here, let's go ahead and pull or do some measurements on the speaker coil, or the voice coil, and the field coil, which is located right here. Looking on the schematic, it says that it should be around 1330 ohms across the field coil, and the voice coil, which has a common leg. So we'll look for the one that's got the how it's wired common, and that'll be one side, and then the other side will be totally free. So we'll check our field coil first, and hopefully, and since it's working, I feel like it's going to be okay, but we'll document this. I always like to write down what it truly is, and then we'll do the voice coil and go from there. Let's look and see what we got here. Maybe you can see in there. It's pretty difficult. It's like working in a box. I guess it is. It is a box. Get to see my new Chinese fluke that I just recently bought. It's stated that it's not to be sold in the United States. Figure that. There's no warranty on it or what have you. Okay, let's go this and this wire, so it'll be these two terminals. Maybe you can see from my hands. And we're seeing, come on, 1321, 1.321K ohms, which that's close to 1330. And then then it'll be these two. And our voice coil is reading, stay on there, 3 point, well, let me get a good connection. Very difficult sometimes. 3.1, that's stable, 2.8. So I think that's good. Let me document these, and then we'll get underneath the chassis. We'll set this aside for right now. We'll work on the speaker and the cabinet totally separate. But let's get under the chassis. I know you guys want to see in there. Here's the underside of the chassis. It's pretty crowded in there. I think we're going to pull. Even though the capacitor doesn't look that bad, this has got the drive itself. It's a rubber grommet, and I've got that ordered, so we'll see. Or the friction drive grommet, or whatever they want to call it, drive washer, or whatever. But right here is probably 90% of all the resistors in the set, and being dog bones, we'll pull this board. We'll probably go ahead and pull it all the way out and do the checks. These are the IF cans, and if you can see, they screw just like a can. You screw it off. Here's the oscillator coils, so I think we move this out and this out, and then we'll have to do a lot of rewiring here. Some of these may not have to, but like this one, we're going to probably replace that. It's really brittle, and working with this as we go through there, we're going to definitely we're going to crack some of them. So while we're here, let's go ahead and do some checks on some stuff. And let's see if you can see the meter. Okay, let's get this over here. We can check the primary. I mean, I'm pretty sure this is all good stuff, because it's working. It's working pretty doggone good. So let's just go ahead and check the primary. We can do that through the line cord. Let's see. Make sure I don't short it out. About 7.6 ohms. That sounds about right for a primary. The antenna. Let's see if you can see this. There's no readings for the transformer, so there's no. But the antenna coil itself is 40 ohms, which we can do that with the two wires that's coming out. Let's go ahead and check that and see. Let's see, here's the black one and the yellow one, and it is a mess here. It is a mess there. And let's see if we can get a reading. 40.3. I don't think we're going to get much closer than that. So it says that's good. Okay. Let me document those, and then we'll turn this down and we'll get some readings up on the top. We check this part of the antenna coil. So let's check this side of it. We said that was 40, and I think it read 40.1 or 40.2. This next side it says 5 ohms. So if you'll look down here, it goes to ground. The other end goes to the, and if you also notice, I have taken my schematic and I've written the pin numbers of the tubes. That helps a whole lot when you're troubleshooting these things. So we can connect our meter to ground, and the cap that goes to the 35 tube, and we should get somewhere in the order of 5 ohms. Let's check that out and see. Any glare or anything. Alright, I've got the meter connected to ground, and let's go to the grid cap itself. And we're reading 5.8 ohms. That's in the ballpark. Okay, let me document that. Okay, let's check the first part of this one. It should read about 58 ohms or so. So I'm going to do it from the top of the chassis. You can do it from the bottom. But what I'm going to do is I'm going to attach to, I'm going to stick it in pin 2 of the 35 tube, which will be the plate, which will be this connection. Then I'm going to go all the way down here to pin 4 of the, where am I at? Pin 4 of the rectifier tube. As you can see, the connection through this coil. So I'm going to read this coil by checking pin 4 and pin 2 of the tubes. Alright, I've already got the other one in pin 4. And let's see if I can find. Now you got to remember these things are backwards. So that's pin, and that's reading 55.6, and it's supposed to be 58. I believe that's good. You get the idea. Just go through, and I'm going to go through and I'm going to check all, even though this thing is working and working fairly well, I'm going to go through and document these, the transformers, the coils, the resistors, especially those dog bones. We'll go through and do those, and because those are notorious to be out of spec. And then we'll make a list to order, and we'll go from there. And documentation is everything. And if you go through it step by step, part by part, you'll get a better feel of what's going on and everything like that. Do I understand everything that goes on in these things? No, I don't. There's a lot of documentation on the internet, and the videos. I watch a lot of videos of other folks, and it's just a lot of fun to figure things out. And but I showed you one way to troubleshoot, or just to check a circuit without going underneath. You can go through the pin sockets sometimes. So let me do this, and we'll pick up a little bit later on and get into some real serious work, tearing that capacitor out. But I'm going to have to clean some of this chassis out on the bottom. so we can get to all this stuff and do a lot of rewiring. It's going to be a time-consuming thing, but feel good that it's working. That's one of the pluses. I always like to get them working before I start tearing them down and rebuilding stuff. So that's just me, but everybody's a little bit different. But we're doing it the way we want to do it, and like I've always said, every time I sit down at this table, I learn something. Now I may forget two things. One of the things that one of my say is people ask me, I tell them, I said, I've been around the block. I have been around the block. But sometimes I forget what's on the other side of it. So that's why you got to keep going around the block. Here's something else that I do, is I save these files as a PDF file, and I'll use my iPad for, especially if I can't read it. A lot of times I'll blow up. I like a hard copy myself, but if it's just something quick and easy, I'll use my iPad. Now I've gone through some of it already, and as I check this, I document the actual readings, and if it's within tolerance, I'll highlight it green. That means that I've checked it and that it's good. If I get over here and I check one and it's out of tolerance, then I will highlight it pink, which means I must replace that part. Now this one, I'm not real sure that I'm going to replace it, simply because it is basically a pattern on the volume control, which is supposed to be 150 ohms, and it's reading 208. So I may very well leave that in there, because I don't think that's going to be that critical. But some of the stuff is good, some of it's not good. But we'll get us a list. We'll order some parts and we'll replace that. This particular resistor here, I'm going to wait until I pull the resistor board out, and I'll go back and check all these other ones that's on that board once I have it pulled out, because I don't want anything to influence it, and I want to make sure I get a good part in there. If I want to do this, I want to do it right, So anyway, it's just going through. I saw this on another video somewhere, and sometimes these things are hard to read. Let's say this is 93, and I'm saying it's 93.5 ohms. Now, the way that someone else, and I'll give them the credit, I'm not trying to give them any blame, but it makes a whole lot of sense that when this was typed or written, they left a space for the period. Through the reproduction of it all, it's not going to be, it has gone away. But if that had been 935 ohms, then there wouldn't be a space there. They would all be together. Same with this 41.5 ohms. And the space is there. So you have to go also look. These are calculations. These engineers have calculated these. The technicians and back in those days, did they have digital meters? No. These numbers are theory. That means when you do your checks, they should be in the ballpark. And that's exactly what the technicians working on these things did. That's what the technicians on the bench setting these things up. These numbers are calculated, especially these readings. Okay, boys and girls, look what a mess I've made. Pull the IF out, pull the resistor block out, and that's labeled all the wires, and just about every one of those wires are cracked and brittle. So probably going to have to rewire most of it. I don't know where you folks come from, but where I come from, that's called a stump full of granddaddies. I don't know if I'll ever get this one back together. I think I will. I just take my time and no hurry. We'll get her done. I'm beginning to think that this interstage transformer going to the output tubes, it's a center tap, and I'm beginning to think one of them's open. Half of it's open. That's a common thing in these radios, my understanding, and I cannot get anything across this transformer. It was playing very well, but if half of it is open, then the other half could have been doing the work. But who knows? We'll get a little further into it as we rewire it and do some more checks and what have you. Clean up. I'm going to take this cap out, this condenser, this tuning condenser, and that'll free up a whole lot more room. Let me know what you think. If I made a mess, will I ever get it back together?